The most used fuel for producing electricity in the world today is coal. Power plants burn it in their furnaces to heat water into steam that spins giant turbines to generate electricity. At least 40% of the world's electricity is produced by coal-fired power plants. Coal developed from prehistoric vegetation that wound up buried underground due to geological changes. Over millions of years, these decayed plants transformed into combustible rock. This is why we refer to coal as a fossil fuel. Coal runs in seams through other rock layers. Miners drill holes through the seam at several locations, then mix together ammonium nitrate and diesel and pour a precise quantity of this liquid explosive into each bored hole. They plug the holes with dirt to contain the upcoming explosion. This directs the force of the blast sideways, so that it will fracture rock as much horizontally as vertically. They place a blasting cap in each plugged hole, then connect all the blasting cap wires to detonation lines through which they'll send an electrical charge to ignite the explosives. They install detonation delays to time the blasts one after another, because successive explosions have greater impact than simultaneous ones. The blasts dislodge and break up the layers of rock between the surface and the coal seam deep below. Workers clear away the rocks and dirt with a mammoth machine called a dragline. Removing the blasted rock and dirt exposes the coal, which is still a solid, hard seam. The side of the mine pit shows how much rock is on top of this particular coal seam. Once miners blast and clear away that rock, they drill and load the holes to set off more explosives to fracture the coal seam itself. Then front-end loaders load the coal into specialized trucks called coal haulers. In one trip, a coal hauler can transport about 220 tons of coal out of the pit to the coal stockpile. From there, rail cars transport the coal to the nearby power plant. When this company prepares to mine an area, it removes the topsoil in which vegetation grows. As part of a land reclamation program, the company stockpiles the topsoil until it finishes mining out the coal. Then it refills the pit with the rock and dirt it blasted away, returns the topsoil, and plants native vegetation. The power plant is situated by a man-made lake, the water source for the steam with which it generates electricity. When the coal arrives, crushers grind it up into baseball-sized pieces. After a strategic blending of different grades of coal to optimize heat output, the coal travels by conveyor belt to indoor silos. Each silo feeds crushers, which pulverize the coal into powder. Now the coal is ready to fuel the furnace. Meanwhile, huge intake pumps draw lake water. The furnace heats the water to 540 degrees Celsius, well beyond the boiling point, transforming it into high-pressure steam. The steam then enters and rotates turbines, generating electricity. By the time the steam exits the turbines, it's thermally depleted, down to just 49 degrees Celsius, and depressurized to a vacuum state. It then passes through a condenser containing cold lake water. The water absorbs the remaining heat, converting the steam back to water, which is then recycled into new steam. The combustion process itself creates sulfur dioxide. The plant runs this gas waste through vessels containing a lime solution to neutralize the sulfur. This chemical reaction creates water vapor, which exits the plant's stack. Wires coming off the turbine generators carry the electricity to outdoor transformers, which convert it to higher voltage in order to have less energy loss, as the power from coal travels through transmission lines to some 350,000 households.